To enhance the understanding of motor drives, several books are recommended. Firstly, Motion Control Theory and Practice by Stephen B. Chapman. Secondly, Electric Motor Drives Modeling, Analysis, and Control by R. Krishnan. Thirdly, Advanced Motor Control for Industry by Lucas Strasser. Both frequency drives and vector drives are used to control the speed and torque of electric motors. Frequency drives operate by altering the frequency of the alternating current power supplied to the motor, consequently adjusting the motor's speed. Vector drives, however, employ a feedback loop to regulate not only the frequency but also the phase angle of the voltage applied to the motor. This approach allows for finer control over both torque and speed. For measuring voltage and amperage in motor drive systems, a power quality analyzer is highly recommended. This specialized meter is capable of measuring voltage, amperage, frequency, power factor, and other critical electrical parameters. It typically includes clamps for conducting non-invasive current measurements and high-impedance probes for accurate voltage measurements. To effectively troubleshoot motor drives, understanding specific concepts is critical. These include motor theory, covering both alternating current induction and synchronous motors. Power electronics, including inverters and switches. Control theory, which encompasses feedback loops and closed-loop systems. Power factor and harmonics are also important. In addition to these resources, consulting the manufacturer's documentation for the specific drive is recommended. This documentation provides detailed information about the drive's operation, maintenance, and troubleshooting procedures. Consider attending training courses or workshops offered by the manufacturer or educational institutions. These courses provide hands-on experience and in-depth knowledge of motor drive systems. Engaging with online forums and communities dedicated to motor drives can also prove helpful. These platforms allow you to connect with other professionals, ask questions, and share knowledge. Practice troubleshooting by simulating faults in a controlled environment. This helps develop skills and build confidence in diagnosing and resolving issues. To understand motor theory, it is essential to grasp the fundamentals of how alternating current induction and synchronous motors operate. Alternating current induction motors are widely used due to their simplicity, reliability, and cost-effectiveness. These motors consist of a stator, which houses the main windings, and a rotor, which rotates within the stator. The stator windings create a rotating magnetic field, which induces a current in the rotor windings. This induced current generates a magnetic field in the rotor, which interacts with the stator's magnetic field, producing torque and causing the rotor to rotate. Synchronous motors, on the other hand, operate at a synchronous speed, which is directly proportional to the frequency of the applied alternating current power. These motors have a rotor that is magnetized, either by permanent magnets or by direct current excitation. The rotor's magnetic field locks in with the rotating magnetic field produced by the stator windings, causing the rotor to rotate at the same speed as the rotating magnetic field. Understanding the principles of power electronics is crucial for comprehending how motor drives function. Power electronics involves the use of semiconductor devices, such as diodes, transistors, and thyristors, to control and convert electrical power. In motor drives, power electronic converters are used to convert the incoming alternating current power into a form that can be used to control the motor speed and torque. Inverters are a key component of motor drives. They convert direct current power into alternating current power with adjustable frequency and voltage. This adjustable alternating current power is then supplied to the motor, allowing for precise control of its speed and torque. Switches, such as insulated gate bipolar transistors, or IGBTs, are used in inverters to rapidly switch the direct current voltage on and off, creating the alternating current waveform. Control theory plays a significant role in motor drive systems. Feedback loops are used to monitor the motor's speed and torque and adjust the drive's output to maintain the desired performance. Closed-loop systems use feedback signals to continuously adjust the control parameters, ensuring accurate and stable operation. Proportional integral derivative, or PID, controllers are commonly used in motor drives to regulate the motor's speed and torque. These controllers adjust the drive's output based on the error between the desired set point and the actual measured value. Understanding power factor and harmonics is also important for troubleshooting motor drives. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the current is not contributing to useful work. Harmonics are unwanted alternating current voltages and currents that are multiples of the fundamental frequency. These harmonics can cause overheating, equipment malfunction, and other problems. Motor drives can generate harmonics due to the nonlinear nature of the power electronic converters. Filters are often used to reduce the level of harmonics in the system. When measuring voltage and amperage, it's important to select a meter that is appropriate for the application. A power quality analyzer is a versatile tool that can measure a wide range of electrical parameters, including voltage, amperage, frequency, power factor, and harmonics. These analyzers typically have clamps for non-invasive current measurements. This allows you to measure the current without having to disconnect any wires. They also have high impedance probes for voltage measurements. This ensures that the meter does not load the circuit being measured. When troubleshooting motor drives, it's important to follow a systematic approach. Firstly, gather information about the problem. Talk to the operator. Review maintenance records and check for any alarms or error messages. Secondly, inspect the drive and motor for any obvious signs of damage, such as burnt components, loose connections, or damaged wiring. Thirdly, use a multimeter to measure voltages and currents at various points in the system. This can help you identify any faults in the power supply, inverter, or motor. Fourthly, use a power quality analyzer to measure the power factor and harmonics. This can help you identify any problems with the power quality. Fifthly, consult the manufacturer's documentation for troubleshooting tips and procedures. The documentation may contain specific information about the drive's operation and common problems. Remember, safety is paramount when working with electrical equipment. Always de-energize the circuit before working on it, and use appropriate personal protective equipment, such as gloves and safety glasses. Understanding the underlying principles of motor drives, using the right tools, and following a systematic approach can effectively troubleshoot and maintain these systems. The knowledge gained from books, training, and hands-on experience will contribute to a deeper understanding and improved troubleshooting skills. Always prioritize safety and refer to the manufacturer's documentation for specific guidance. By continuing to learn and practice, proficiency in working with alternating current vector drives and other motor control systems can be achieved.